Exercise 1.4, question 1. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. Now, what is all of this about? Let's talk about what we see here in a page from your book. Okay, so from class 9, we already know that whenever you have a rational number, then it can only have two kinds of decimal expansions. Either the decimal expansion will be terminating, which means it will be ending, it will end somewhere, or if it is non-terminating, that is, if it does not end, then there will be something repeating. So these are really the two kinds of decimal expansions that rational numbers can have. Now we have a theorem here in our book for class 10. Let's read this. We're saying let x be a rational number whose decimal expansion terminates. So it is not any of these. We are sure that it is going to terminate. Then x can be expressed in the form p by q. Well, this can be for any rational number. But what is so special about x? X can be expressed in p by q, where p and q are co-prime, and the prime factorization of q, which is the denominator, is of the form 2 to the power n times 5 to the power m, where n and m are non-negative integers. Now that is a lot of words. It's a huge statement. Let's just try to understand what this is, and then we'll see how we can apply this in our question here. Well, just look at these two very simple examples. So I have 2 by 5 and the other one, let's take 1 by 3. Now both of these here are rational numbers. You can clearly see that I've written them in the form p over q, where p and q are both integers. Also, they are co-prime, that is, I cannot cancel them any further. 2 and 5 are co-prime, 1 and 3 are co-prime as well. Now how do I know which one is terminating and which one is non-terminating repeating? Well, till now I might really have to divide and check. Let me just do that. These are two very small divisions. I'll pause, you do it, and then resume to see my division. Alright, here you go. So when I divided 2 by 5, I got this decimal expansion 0.4. So the decimal just ends here after the 4. I'm not going to have any more digits. So this one, where it just ends, this is what you call a terminating decimal expansion. Well, when I divided 1 by 3, again I needed a decimal because 1 was smaller, it became a 10. 3 threes are 9, the remainder was again 1, which was again smaller. So yet again I put a 0, and then again 3 threes are 9. When you again got the remainder as 1, you might have realized already this is never gonna end. This will keep repeating, and therefore the decimal expansion that you have here is really 0.333333 forever. Now there's a way we represent that. We can just write down the digit that repeats a lot and put a bar on it. The digit that repeats forever, you have a bar over that. Now this is an example of an expansion that will never end. So this is why we call it non-terminating. The word terminate means to end. But it's not just something that doesn't end. It is something where digits repeat. You can see how the 3 constantly repeats. And that is why the complete explanation, the complete name for the kind of expansion would be non-terminating repeating. Now here I had to do long division, but my question says I should not have to do long division and I should directly tell this. Well, then comes this theorem to our rescue. It says it is going to be terminating if after you get your fraction in the lowest form, in the simplest form, if the denominator is of the form 2 to the power n times 5 to the power m, which in simple words just means that the prime factorization of the denominator should have only 2's or only 5's or both of them. Nothing else. No other prime number, no other prime factor other than these. Now when you check it here, in 2 over 5, the denominator is 5 only, so it has only a 5 and therefore it matches what we wanted. But here in the second one, it's a 3. So it is something other than 2's and 5's. It's not just 2's, not just 5's, not both of them. It's something else. So therefore, this is not terminating. And if it is not terminating, then the only other kind left is non-terminating repeating. While this one, matched our checklist for terminating. So that is the simple test. You have to get your rational number in the lowest form first, and then you need to prime factorize the denominator. If it has just 2's and 5's, it will be terminating, otherwise non-terminating, repeating. Now I'll start with these problems one by one. Before you see my solution, try this first part out. If you get stuck with the first part, it's okay. I'll do that for you, and then you try the next parts onwards. Well, if you look at the first part first of all and try to get it into the lowest form, you would realize this is already in the lowest form. 13 and 3125 already have no common factor. So then the only thing we need to do is we need to prime factorize the base to see what this is made up of. So let's prime factorize 3125 together. So first of all, I can see that it ends with a 5, so definitely 5 is a factor, and this is what it will be. Yet again, 5 is a factor. I will get 125. Then again 5 times 25, then 5 times 5, and 5 times 1. Wonderful. So all I got here was a bunch of 5's. It's really 5 of them. This one is 5 to the power 5. That means my denominator is made up of only 5's, and therefore this is definitely going to be terminating. See, I don't need to do any division. It was such a quick answer. If you just see it for the core definition, it says 2 to the power n times 5 to the power m, then it's really 2 to the power 0 times 5 to the power 5. Clearly, these two here are non-negative integers. Non-negative just means they can't be negative, otherwise they can be 0, they can be positive. So it matches it. But really, the easy way to think of this is this, but the proper way to write it, because you want to match it with the definition given in your book, this is how you need to do it. Then when you see 17 over 8, it is yet again in the lowest form, so you just have to prime factorize the denominator. You will get 2 to the power 3. Yet again, it is only 2's, so this is also going to be terminating. And if I write it in the form that the book wants it, then this is how it's going to be. Yet again, 3 and 0 are both non-negative integers. Now here are the next two parts. Please pause the video, try them on one time, and then when you will play the video, you will already have seen, you will already see the lowest form of these, if any, and then you will see the prime factored form. Okay, here you go. I hope you tried. In this first one, 64 over 455, it is already in the lowest form. There is nothing that you can cancel between these two numbers. So we just prime factorize the denominator, and this is what we get. Clearly, this is not just 2's or 5's. You have a 7, you have a 13. And as I said, if it's anything other than 2's and 5's, it is not going to be terminating. And if it's not terminating, then it's going to be non-terminating, repeating. Next up, 15 over 1600. This time I can cancel them out because these two numbers are not co-prime. They have a common factor 5. Now when I cancelled that, I got 3 over 320. But now these two numbers are co-prime, so I cannot cancel them any further. I will prime factorize my denominator. Now when I did that, I have only 2's and 5's. I have 6 2's and 1 5. So because this is of this form, 2 to the power n times 5 to the power m, this is terminating. What is n for you? What is m for you again? If you want to be very clear, this is n, 6, and this is 1, m. Both of these are clearly non-negative integers. Here are two more parts now. Yet again, I give you the same chance. Pause the video, try them, and when you play, you will see the solution. Alright, I hope you tried. This time you will see on the screen I haven't done the complete prime factorization. Well, that is not even required here to get what we want. Think about it. This is already in the lowest form. First of all, I need to prime factorize the denominator. The moment I know that 7 is one prime factor, 7 times 49, do I need to even go on? I already know from this stage that it's not just going to be 2's and 5's. I found something else. I found a 7. And therefore, this is definitely going to be something which is not terminating. So it will be non-terminating, repeating. That's it. Sixth part now is super simple. These nice people have already done the prime factorization for us. So this is nothing that you can cancel out here, and your denominator clearly is of the form this, only 2's and 5's, where, let me just write this down, you can see that n is equal to 3 and m is equal to 2, and both of them are what? Non-negative integers. So this one then is terminating. Without dividing, I am sure that this expansion will definitely end. Time for the next two, you know the drill. Pause and try. All right. So this first one, already in the lowest form, nothing that I have in 129 that I can cancel this with. Now when I see the denominator, it's already prime factorized. I can see it's not just 2's or 5's. You see this highlighted 7 to the power 5? That means it has one more prime factor other than the ones that I'm allowed. So it's not terminating, and therefore it's the other kind, non-terminating, repeating. In this eighth part now, I can simplify them. So I will not just start with 15. It's a mistake if I don't simplify this first. If you don't, then you will see, oh, 15 is 3 times 5. Then you'll think, okay, I have something other than 2's and 5's, and you will just call this non-terminating repeating. But that would be wrong. Why? Because once you simplify, the denominator really has just a 5. So since it's only a 5, it can very well be written in this form where you just take the 0th power of 2, and therefore this is terminating. Here are the last two parts of this long question. Try them and play to see the solution. Alright, so this first one, we had scope for some simplification. We just simplified both numbers by a 5 and we got 7 over 10. Then when we prime factorize the denominator, it's just 2 times 5, so powers are 1, and therefore only 2's and 5's, this is terminating. Last part now, yet again, you had some scope for simplification. You could cancel out a 7 from both of them, so it's 11 over 30. Now 30, when you prime factorize, it's 2 times 3 times 5. So there is something other than 2's and 5's, so it's non-terminating, repeating. And we're done.